Welcome back to the solutions manual. In this video, we will solve the problem 1-97 from RC Hibbeler Mechanics of Material 8 edition. According to this problem, the rods A, B, and CD are made of steel having a failure tensile stress 510 megapascal. Using a factor of safety of 1.75 for tension, we have to determine their smallest diameter so that they can support the load. The beam is assumed to be pin connected at points A and C. Now to solve this problem, first of all, we have to draw all the forces. So apart from the external three loads, we have the tensile forces due to the rods AB and CD. Now we can apply the equations of equilibrium. So our first equation would be, let me just write it as FAB, and this would be FCD. So our first equation of equilibrium would be summation of moments at point A equals to 0. I'm considering counterclockwise direction as positive. So at point A, the force FAB is passing through and it will not produce any moment about the point A. The 4 kilonewton force is trying to rotate the beam in clockwise direction about the point A. So the moment produced by this 4 kilonewton force would be taken as negative. And the moment arm is 2 meters. Now this 6 kilonewton force is also trying to rotate the beam in clockwise direction about point A. So the moment produced by this 6 kilonewton force would also be taken as negative. And the moment arm is 2 plus 2 meter, that is 4. Also the 5 kilonewton force is also trying to rotate the beam in clockwise direction about point A. So the moment produced by this force will also be taken as negative. And the moment arm is 7 meters. This tensile force FCD is trying to rotate the beam in counterclockwise direction about point A. The moment produced by this FCD force would be taken as positive. And the moment arm is 10 meters equals to 0. So upon simplification, our answer for FCD force comes out to be 6,700 newtons. Now we have to do the same procedure for the FAB force. So our second equation of equilibrium would be summation of moments at point C equals to 0. I'm considering counterclockwise direction as positive. The FCD force will not produce any moment about point C because it is passing through it. So it does not have any momentum from point C. The 5 kilonewton force is trying to rotate the beam in counterclockwise direction about point C. So the moment produced by this force will be taken as positive. And the moment arm is 3 meters. Similarly, the 6 kilonewton force and 4 kilonewton force are also trying to rotate the beam in counterclockwise direction about point C. So the moment produced by these two forces would also be positive. And their respective moment arms are 6 meters for 6 kilonewton force and 8 meters for 4 kilonewton force. The FAB force is trying to rotate the beam in clockwise direction about point C. So the moment produced by the FAB force will be taken as negative. And the moment arm is 10 meters. So upon simplification, the value of FAB comes out to be 8,300 newtons. So now we have to find the diameters. for, let me write it, FCD, and this column is for FAB. If you recall, the formula for factor of safety is sigma failure over sigma allowable. Here, factor of safety for both of the rods is 1.75. And the failure tensile stress is 510 megapascals. So using those values, we can find the sigma allowable. So sigma allow is equals to 510 megapascals divided by 1.75, the factor of safety. So from here, sigma allowable comes out to be 291.43 megapascals, or you can write it as exponent 6 pascals. Now, if you recall, the tensile stress can also be written as sigma allow equals to FCD over the cross-sectional area of the rod CD. And here FAB over the cross-sectional area of the rod AB. So from here, ACD is equals to FCD, and FCD, if you recall, is 6,700 newtons. We had previously calculated, divided by the sigma allowable, that is 291.43 exponent 6 pascals. So from here, cross-sectional area of the rod CD comes out to be 2.3 exponent negative 5 meters. And here, the cross-sectional area of the rod AB comes out to be, the FAB force is 8,300 newtons divided by 291.43 exponent 6 pascals. So from here, cross-sectional area of the rod AB comes out to be 2.85 exponent 5 meters. Now, if you recall, the cross-sectional area of the rod would be a circle, because the rod will look like a cylindrical shape, and the cross-sectional area of the cylindrical shape would be a circle. If I cut the rod along this plane, the cross-sectional area would be a circle. So cross-sectional area can also be written as A equals to pi d square upon 4. So from here, for the rod CD, D is equals to 2.3 exponent negative 5 times 4 divided by pi and square root. So the diameter of the rod CD comes out to be, after simplification, 5.41 exponent negative 3 meters. Or you can also write it as 5.41 millimeters. So this is the answer. This is one of the answers for the rod CD. Now we have to do the same procedure for the rod AB. So again, the formula is same. (2.85 exponent negative 5 meters). So D is equals to square root of 2.85 exponent negative 5 times 4 divided by pi. So from here, D comes out to be 6.02 exponent negative 3 meters, or d equals to 6.02 millimeters. So this is our second answer. So this is it for this problem. I hope you will find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts about this problem, then feel free to ask in the comment section and I will answer it as soon as possible. Thank you.